Hi. This module will talk about confidentiality. To implement confidentiality, what we want to achieve is to hide the message or resource from unauthorized access. A large part of this is implementing encryption technology. Encryption is a component of cryptography, which is a larger field of study including hashing, and ciphertext, etc. For encryption, it is a two-way function. You must be able to encrypt and be able to decrypt. In essence, it involves a key or a secret that is used to scramble the original message. Only the people, who possess the key or secret, can reassemble it back. One of the famous encryption machine used, is the Enigma in World War II. Generally, encryption can be grouped into two types: symmetric and asymmetric. Symmetric encryption means both sender and receiver uses the same key and same algorithm to encrypt and decrypt. Asymmetric encryption is also known as public key cryptography, uses different keys to encrypt and decrypt. Also known as public-private key pair. The sender uses the receiver's public key to encrypt, and the receiver will his own private key to decrypt. Another important concept to understand is block cipher, and stream cipher. Block cipher means encrypting a block of bits. Stream cipher means encrypting one bit at a time. You can read up more to understand the mechanics of the algorithms. Next, we will go through the well-known encryption. Here are some of the common symmetric algorithms. Data Encryption Standard, or DES, is an old standard, and is now obsolete, as the key size is too small. It is a block cipher. It uses 56 bits, as the actual key, and the remaining 8 bits are used for error correction. Next, Triple DES is an upgrade of DES, and it uses 3, 56 bits DES key, typically 3 different 56-bit key, which adds up the key size to 168 bits. Note that, it does not encrypt the plain text 3 times with the 3 keys. It uses the DES encryption algorithm, to encrypt the plain text with the first key. Uses the DES decryption algorithm with the second key, on the result of the first operation. And uses the DES encryption algorithm, with the third key on the result of the second operation. In the year 2001, the National Institute of Standards and Technology selected the Rindell algorithm as the Advanced Encryption Standard or AES, after 3 years of selection process. It is a block cipher, and supports key sizes of 128, 192 and 256 bits. Next is RC, also known as reverse cipher or Ron's code. It has 3 levels, RC4, RC5 and RC6. Note that RC4 is a streaming cipher. RC4 is commonly used in wireless, WEP or WPA encryption, and BitTorrent protocol. RC5 and RC6 are block ciphers. RC6 was a candidate for the AES selection process. Another AES candidates were Blowfish and Twofish. Invented by a team led by Bruce Schneier. It is a block cipher. Finally, International Data Encryption Algorithm or IDEA was developed by a Swiss consortium and uses a 128-bit key. This product is similar in speed and capability to DES, but it's more secure. IDEA is used in Pretty Good Privacy, PGP, a public domain encryption system many people use for email. Next, let's take a look at asymmetric algorithms. It makes use of a very interesting mathematical behavior, to encrypt and decrypt the message. In an asymmetric algorithm, each entity has public-private keys pair. The public key can be known to everybody. But the private key is kept a secret to the entity only. The sender will encrypt the message with the receiver's public key. The mathematical nature is such that only the receiver's private key can decrypt it. In plain terms, the key to use to encrypt is not the same key used to decrypt, hence the term asymmetric. Unlike symmetric encryption which uses the same key. One of the most commonly used asymmetric algorithm is the RSA algorithm. It is named after Ron Rivest, Adi Shamir, and Leonard Adleman. The RSA algorithm is an early public key encryption system that uses large integers as the basis for computation. It is also a de facto standard. RSA is used in many environments, including Secure Sockets Layer, SSL, PKI, and digital signatures. Next, we have the DiffieHellman algorithm. Whitfield Diffie and Martin Hellman are considered the founders of the public-private key concept. Their DiffieHellman algorithm is used primarily to generate a shared secret key across public networks. It is very common to see this setting in a VPN configuration. Finally, we have the elliptic curve cryptography, ECC. It uses smaller key sizes to obtain the same level of security as RSA algorithm. ECC encryption systems are based on the idea of using points on a curve, combined with a point at infinity, and the difficulty of solving discrete logarithm problems. ECT stands for elliptic curve DiffieHellman ephemeral, and it is a key exchange mechanism based on elliptic curves.